Okay, as of right now, what do you know about the sine of any angle in a right angle triangle? It is opposite over hypotenuse, yes? Okay, what do you know about the cosine of every right angle triangle? It is adjacent over hypotenuse. And what do you know about the tangent? It is opposite over adjacent. We know all of that, yes? Okay, you must have that in your head. You've got it locked in. I'm pretty confident with that. Now, here we have the Cartesian plane, yes? You might also know this as the coordinate grid. It has numerous names that it goes by. This is the x's, this is the y's. It has been divided into 4. What are they called? Quadrants. Absolutely right. This is quadrant 1. And in quadrant 1, every x value is positive and every y value is positive. Everybody gets that, yeah? Okay. This is quadrant 2. We go counterclockwise. Don't ask me why. In quadrant 2, what are all of my x values? Negative. And what are all of my y values? Positive. This is quadrant 3. All my x values are negative and all my y values are negative. And this is quadrant 4, where all my x values are positive and all my y values are negative. Is everybody cool with that? All right. Now, everybody, if you have a different color pen, it would be useful. If you don't, it is no big deal. Everybody draw a line along the x-axis. Right along the axis. You can use anything you want, Carmen. Just as long as there's a line on your x-axis. Everybody is drawing that, yes? Have I drawn an angle yet? No, I have not. Jenna says I have not. Why have I not drawn an angle? Why have I not drawn an angle? What does an angle need? 2 parts, 2 rays, yes? So I don't have an angle yet, do I? Now, draw an angle out into the second quadrant. Now, do I have an angle? Everyone agree? Everyone's good? Okay. How do we measure that angle? We measure that angle this way. That is our theta. Okay? Now, please notice something. That is different than the previous example I gave you that used the coordinate grid, isn't it? The previous example I gave you that used the coordinate grid was for directions, yes? North, east, south, west. And where did we start? At north. Are we starting at north now? No, we are starting down here. And when we go north, east, south, west, we go to the right. We go clockwise, don't we? What did we do here? We went counterclockwise, or if you're from Britain, uncle-clockwise. No, anti-clockwise. Anti-clockwise, uncle-clockwise. We say counterclockwise, the British people say anti-clockwise. So I say uncle-clockwise. Okay? I always love it when I have somebody who's British, because they say anti. All right, everybody cool? Is everybody good? Everyone is good? Okay. This arm that we started, because that's where we started our angle from, is called the initial arm. Please do something to remind yourself that that is a new piece of vocabulary that I'm going to be using a lot. Highlight, put a star by it, put a Mrs. Bad Crumble cloud around it. Whatever you need to do to make sure you know that that's an important word. To have an angle, you have two parts, yes? We have named the first part, so we must now name the second part. The second part is what is called the terminal arm. Why is it called the terminal arm? Because that is where the angle ends or terminates. Everybody cool? All right. Now, the next piece of vocabulary is this word right here. An angle is in standard position if the vertex, what's the vertex of an angle? The corner. If the vertex is at 0, 0, right there, is our vertex at 0, 0? Boom, boom. Is the corner right at 0, 0? Yes. And the initial arm, where's the initial arm? It's the first one we wrote, is the x-axis. So, is our green angle I drew here, is it in standard position? Yes. Its corner is on the 0, 0, on the origin, and its initial arm is the x-axis. Everybody cool? Okay. Excuse me. The other ray is the terminal arm, which I've already named for you. It's the terminal arm. I'm going to shrink this down a little bit so I can get more on the screen. I know it's a little tougher to see, but it's only for a moment. I just want you to be able to see everything in one spot. Everyone's cool with this, yes? Okay. Counterclockwise rotation. So, on our grid that way, counterclockwise is positive values. Clockwise is negative values. So here's what I mean. You guys are smart kids. I start counting from the initial arm. I went up. I went clockwise, yes? So this angle, theta, is a positive angle. Agreed? What must it be? Can it be less than 90? No, it must be more than 90. Can it be 180? No. It has to be between 90 and 180. Just like in directions. Is everybody good with that? Everybody can read one of these things? Okay, now just like in directions, everything's a 90. So this is 90, this is 180, this is 270, and this is 360. Cool? Now, you guys should be, your page should have ended right there. Yes? It did for everyone, right? Okay. Turn the page over. And it's pretty obvious what you need to do now. But I'm going to do the first one with you. Sketch the angle in standard position. What do we know about standard position? Where does the first part of the angle have to be? On the x-axis. So they're all going to be along here, aren't they? Right? Okay. Where is 30? It's going to be a third of the way to 90, yes? So we're just sketching it. Everybody good? Okay, where's 135? It's exactly halfway between 90 and 180, yeah? So, cool? You guys draw the next 4, and then I'm going to get you to draw 2 more. I want you to draw one of negative 75 degrees. And I want you to draw what you think 425 degrees would look like. I have not shown you either of them. I want to see if you understand this concept. But do C, D, E, and F first. That's okay, I'm recording now. I'll show you all. So I start there. Now, how do I do 425? Go ahead.
Okay, I think you go all the way around plus up, so I was guessing quadrant one.
Yep, you go all the way around 360 and another 65. Everybody cool? What if it was 790 degrees? What would you do? You'd have to go around twice and add 70, yes? Everybody good? No liars. If you're lying, you're dying. Okay. Okay, you guys are smart young people. Given an angle in standard position. What does standard position mean? It's on the x-axis. And the vertex is at 0, 0, yes? If you have that, you have the angle in standard position. But you also make a second angle, don't you? And that second angle is what we call the reference angle. And the reference angle is between the terminal arm okay, and the x-axis. All right? Everybody understand? So we're going to do 4 examples. So you notice I haven't given you any numbers yet. Yes? Okay, we're going to do 4. The first one we're going to do is an easy one. I'm going to give you a standard angle in black. You're going to draw it on here. Okay? 45. How do I draw an angle in standard position of 45 degrees? Where does the angle start? On the x-axis. And where does it go? That way, because we are going positive. And it's going to go halfway, yes? Everyone agree? Okay, that is my angle in standard position, yes? Okay, what then is my reference angle? Look closely, it's not hard, it's not a trick. The reference angle is between the terminal arm and the x-axis. Where's the terminal arm? It's right here, right? Here is my terminal arm. Where's the x-axis? Right here, right? So what's the angle between the two? Tavleen? No. 45. Yes, this is the x-axis, this is the terminal arm. It's going to be the same. So my reference angle is 45 because it's still there. Everybody got it? Now somebody will say, why isn't it this one, like Tavleen? Why isn't it 135? Why isn't it 135? Why isn't it this one? It's math class, guys. What are math? All mathematicians are lazy, yes? It's the closest one. Cool? All right? It's the closest x-axis. Don't give me away, Jenna. So knowing what you know now, draw me a standard angle, and let's make it 115. So draw him. Or her. Depends. I mean, it's an angle. You shouldn't really assign it a gender. It may not have made its mind up yet. Where is 115? Out here, yes? So theta is here, 115, yeah? What is my reference angle? 65. Why? How did you know it was 65? Bavneet? I already said you could go when she got back. How did you know it was 65? Why was it 180 minus 65? Why was it 180 minus 115?
Because this is 180 and you're already taking out 115.
I went all the way to 180 and then I had to count backwards 65. Everybody cool? And how did you find that? It was 180 minus 115. Everybody good? All right, now I'm going to really mess with your heads for the third one. The third one, your reference angle is going to be 227. Where's that? So I start here. And I start going around. What's that? What's that? What's this one? 270, so it's got to be in here, yes? Okay, what's the reference angle? 47.
Wait, you said on pools.
Oh.
Yeah, that's...
Shh. What's the reference angle? 47. Why? So that is
Would it be
227
minus 180?
minus 180. Because you used up this 180 here. Okay. Is everybody Gouda? Okay, so now I'm really going to mess with your head. Your standard position angle is negative 78 degrees. Where does that one need to go? What quadrant? Fourth. And what is your reference angle? 78. Why?
Because you can't go to the 270.
Because you can't go all the way back there because it's more than half. What is the real measurement of this? What's the positive measurement of that? $282. Because we go all the way around. So negative 78 also equals 282 degrees. So you will notice that 282, 78, and 360 will help you out. How? How do you know that was 78? It was 360 minus 282. Everybody cool? The only thing you can do now is practice it. So there are 4 standard angles. These guys are all standard. Draw them, and then add in the reference angle. While you guys are drawing them, I'm going to be looking at your outline. Just keep drawing all 4. Okay. We're only going to do the first 2 right now. Where is the standard angle of positive 15 degrees?
It is.
Just a little bit up, yes? I've obviously exaggerated it. Why? So you can see it, right? So if my standard is 15, what's my reference? Which I will do in red. It is 15 because it is the closest x-axis. Cool? All right. What is B? It's going to go out here, yes? So where is the reference angle? Is it there or there?
There.
It is in here. There is my theta. I lie. I'm the worst kind of liar. There is my reference angle. And what is it? 60 degrees. Why? Because I came all the way out to 180 and then I went back 60 degrees. Everybody good? All right. I'll wait a moment while you complete C and D. When you think you have C and D, tug on your right ear. It's a test to see who knows rights and lefts.
Left. Are we talking about your right or my right?
What did I say?
On your right.
There you go. If I said tug on my right ear, what would you do? Wrong. You would walk all the way up to the front and grab this. Duh. Of course you wouldn't, because that would be weird for all of us. But if I said tug on the ear that is on my right, then what ear would you tug? Left. Oh, you guys. Can't fool you. All right. So, where is the standard angle? What quadrant? Quadrant 3, down here. Swoop. Right? So it comes all the way around to there. But where's the reference angle? Swoop. And since I'm going away from 180, we are adding 180 plus what to get to 250? 70. This is 250 minus the 180 that is right there, so it is 70 degrees. Cool? And finally, the one that for some reason really causes people trouble. 350 all the way around to here, yes? Well, what's the closest x-axis? Right in there. So what's my reference angle? 10. Is everybody good? Yes? Going once, going twice, going thrice. Priyanka. Because it's to the closest x-axis. This is a y-axis. Cool? Fatima.
For A, why was if it was 15, why was the reference angle 15, and then for 350, it's still pretty close to wouldn't it still be 350?
No, because it's the angle between the x-axis and the terminal arm. The closest x-axis.
But then why was A...
What's closer? This x-axis or all the way around to there? Which would you rather walk? The closest one, 15. So it's 15. Okay? Is everybody good? Now, you guys should be starting to be aware that stuff we taught you in the 9th grade, 8th grade, 7th grade, 6th grade, 5th grade, 4th grade, 3rd grade, 2nd grade is coming back to be of fruitful use here in the 10th grade, isn't it? Shotzi is laughing at me because I said fruitful use because it sounds funny. But when something is fruitful, that means that he's successful. So, all that stuff that we taught you before is important now. So you guys should be on page 72, and it should say this. Yes? All right, now, what has changed? You already know how to deal with the coordinate grid for angles. I just taught that to you. What is this? Coordinates. Where is 3, 2? In the first quadrant. How do I find 3, 2? I go out, 1, 2, 3, and I go up, 1, 2. There is 3, 2. Agreed? Now, have I done my grade 10 work yet? No, that's grade 9 work. In grade 10, I want you to draw that angle in standard position, yes? So what would it look like? First part of the angle is on the x-axis. The other part of the angle goes to there, yes? Is everybody cool with that? Great, draw 7 more. Go. Was everyone able to draw them all? That's okay if your lines are shaky. Just don't be a surgeon. Although that new funny, have you guys see those commercials for Let Go? That app that you sell stuff? The one where the guy's hanging off the truck and he's got to sell his bowling ball. And the one where the guy's in space and he's got to sell his stereo. The newest one is a surgeon. And they show the knife about to cut into the woman's face and it's shaking. And the nurse says, maybe you should let your absciser go. And the camera pulls back and the doctor has that electric thing on his belly that makes your belly shake. That's supposed to shake up the fat to make your fat disappear. And the doctor, just let it go, doctor. And he puts it on let go. And then like some guy walking by is in like a body cast. I'll take it. It's a funny ad. I know it's hard to see ads because in the age of the PVR and Netflix and Show Me or whatever you're using now. Show Me's already gone. I think, is Crave still around? Show Me's gone. Huh? Maybe Crave is gone and Show Me is still around. Crave is still around too. And Hulu and Amazon Plus and all that. Right? Apple TV, right? So anyway, everyone's cool with drawing these, yes? All right, now I am going to do something crazy. Is everybody ready? I'm going to zoom in. You can't zoom in. I'm going to zoom in, though. I have my reasons. All right. Now, this angle that I have made right here, yes? How far did I go this way? 3. How far did I go that way? 2, which gives me this shape. 3 and 2, doesn't it? What math can I do now? Pythagoras, which means this is what? The square root of what? 3 squared plus 2 squared, which is 13, yes? So this is the square root of 13. Don't find the square root of 13, just leave it like that. Is everybody cool with that? Everyone? All right. Now do this one. How far did I go this way? Really? I went 5, yes? But on this graph, what did I do? I went -5, didn't I? Everyone agree? How far did I go this way? Look again. -1, right? How long's the hypotenuse? Square root of what's -5 squared? Really? 25. What's 1 squared? -1 squared. What's 25 and 1? So that is the root of 26, correct? Everybody with me? Okay. What's this one? How far did I go this way? 2. How far did I go this way? -4. What's the hypotenuse? Is the square root of 20. What? Okay, just to remind you, a squared plus b squared equals c squared, yes? What happens to every number when you square it? It's always what? As soon as you square a number, what is the answer? Always. Positive. What's a negative times a negative, dude? Okay, while Max proves this to himself, the rest of us are going to continue working.
There's no negative button here. Oh, yeah, there is.
Make a 90-degree triangle. Where does it have to be? Here and here, yes? How far did I go this way? Negative 10. How far did I go this way? 5. So what's the hypotenuse? Square root of 125. Everybody cool? You must stop me if you are nowhere near understanding here. You must stop me. If you are on your way to understanding, let it go for a couple more examples. See if you get it. Dude. Oh my. Time out, everyone. Talk amongst yourselves.
No, but like...
Dude, just wait a second.
No, it works like this, but...
Dude, I'm about to explain it to you. Okay? Where is that point on the number line? There's 0. Where is that point? To the right or left?
Right.
To the right. It's out here at 9, yes? Now square that. That is 9 times 9, yes? You with me? All right, and that equals 81, yeah?
Yes.
Where is this point on the number line?
Negative.
Right, so it's out here, yeah? What does squaring mean?
Times it.
By itself, right? So if I want to do negative 9 squared, it has to be negative 9 times negative 9, doesn't it? What are two negatives? When you multiply them, what do you get?
Yeah, no.
No, just, Max, don't pick up your calculator. I'm trying to stay calm
No,
here.
it's 81.
Use your brain. What is it?
It's 81.
81, correct? Because two negatives always make a positive, yes?
Positive and negative and negative.
I
Right?
just wanted
I'm about to explain it to you, Max.
to say something, but...
Okay, what do you want to say?
I wanted to say it was like, I know that a negative times a negative is positive. I know all the stuff. It's just that my calculator said different.
And I'm about to explain why.
Okay.
Your calculator didn't say differently. Your calculator did exactly what you told your calculator to do.
Oh.
Your calculator, when you did negative 9 squared, bed mass, right? Brackets exponents, yes?
Oh.
So what is the first thing your calculator did here?
Minus.
No. Bed mass, brackets exponents, division, multiplication, right? So the first thing your calculator did was 9 squared, yes? Which is 81. Then it dealt with the adding and subtracting. Then it put the negative.
So if I put a bracket...
You would need to do that to square negative 9.
Okay, thank you.
Okay? Now, why I was getting frustrated with you is because all of you guys believe your calculator before you think. All right. Okay. Let's look at E. Now, please notice E, F, G, and H are all pretty similar, aren't they? All right. How far did I go this way to make my 90-degree triangle? 4. How far did I go this way? 2. Now, I'm going to do the hypotenuse in all the steps. Every hypotenuse is leg squared plus leg squared equals hypotenuse squared, yes? So, this is the square root of what's the first leg? 4 squared. Plus, what's the second leg? 2 squared, which means I have the square root of 16 plus 4, which is 20. Cool? Good? Everybody good? What is different in F? I have negative 4 and positive 2. But, how do you find hypotenuse? Leg squared, yes? What is negative 4 squared? Positive 16. So this is still the root of 20, isn't it? What is different here? Negative 4, negative 2. What is negative 4 squared? 16. What is negative 2 squared? Positive 4. What is 16 and 4? Root 20. And finally, 4, negative 2, still root 20. Yes? Is everybody cool? Now, please answer this question in your head. What must every value of every hypotenuse be? Positive or negative? Not so good at answering in your head, but yes. Indeed. Hypotenuses are always what? Positive, regardless of direction. Why? Why is your hypotenuse always positive, no matter where I go? Because as soon as you square it, you get a positive value. Do you all understand that? Is everybody cool? Okay, so now this is what you need to take away from that. I'm going to throw a science word at you. How many of you have done Science 10? Okay. In Science 10, if you had a skateboarder who moves that way 5 meters, what would you put in front of that 5? Why? Because he is going to the right. That is a vector. Why? Because it has a distance and a direction. Now, if I told you he skated 5 meters, where can he go? Anywhere. And that is a scalar, because that is what we call a magnitude. It is simply a distance. Okay? Your hypotenuse is scalar. It is just a distance because it is a mixture of positives and negatives. Because it's diagonal. It's an oblique line, so we have to mix the directions. So we just give it a scale. Is everyone cool? No matter what happens to the legs, the distance you travel, if you were to walk, if I walk 3 steps this way, 1, 2, 3, and I walk 4 steps this way, 1, 2, 3, 4, I'm going to be where Kaylin is, right? How far am I from home? 5 steps. Because the hypotenuse is 5. You don't know which one I do first, do you? For me to get to Kaylin would take 5 steps to go straight to him, yes? But if there was a bridge over there and this is a raging river, I would have to go that way then that way, yes? Right? So you would know what directions I took. But if I just say I went from here to there, you have no idea how I started and how I ended. All you know is that I moved 5 steps. Cool? Absolutely essential that you understand this before we move on. Does it matter where I go when I am measuring the hypotenuse? Does it? Doesn't matter. Everyone's cool? Okay. We need to go on. There's no work yet. That is background. I know, right? Okay, turn the next page. The unit circle. First of all, I'm going to define that. Think back to grade 3, Mrs. Bad Crumble. Right? That's my nickname for all elementary school teachers. Okay? Because when I was a kid, every elementary school teacher was old. I don't know how it happened. I don't know when the shift came that elementary teachers became young people. But it did, because all of you guys had young, mostly women for your teachers, didn't you? Right? Every one of my elementary school teachers, every single one, was well past 40. I think. I was 7. But it seems to me that they were old. In grade 6, I had a student teacher who was super pretty because she was like 21. And my regular teacher was 70. And my other regular teacher, I had 2 teachers in grade 6, was 40. Okay? I've already told you the story of one of my grade 6 teachers. She was the one that was taken hostage in the Congo and fought her way out. I haven't told you that story about her? Yeah, you guys think I'm tough? My grade 6 teacher fought her way out of a Congolese hostage camp. Yeah, you think I'm mean. Miss Reed got out of a hostage camp and then wrote a book about it.
Well, you know a lot of things.
Okay? No, I just know people that have done stuff. Okay. When you asked Mrs. Reed what she did on the weekend, the answer was never nothing. Okay, everybody cool? Everybody cool here? Okay, we're back in elementary school. Okay, think to grade 3-ish. Hundreds? Tens? Most of you maybe had your teacher call this ones. Hopefully you had a teacher that said units. But even if she didn't, it's okay, because numbers are counted by 1, aren't they? 1, 2, 3, 4. So the units we use are 1. Everybody with me? So a unit circle is the circle with a radius of 1. Okay? Everybody with me? So on this thing, you guys won't be able to do it perfectly. Draw, please, a circle-ish. It's supposed to be right in the middle. Draw something that looks like that. Everybody cool? It doesn't matter if it's not perfect. Just draw a circle with the center approximately there. Everybody good? Now, if it has a radius of 1, how far is this? How far is this? 1 as a scalar. What is it on the graph? Positive 1. Cool? Everybody agree? Yeah, 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 yeah. Yeah, yeah, yeah. What is this? Positive 1. What is this? Negative 1. And what is this? Negative 1. Everybody cool? Everyone agrees, yes? So if you're lying, you're dying. Okay. Now, draw me a diagonal radius in the middle here. This is going to confuse some of you, so I'm going to go slowly. How long is the blue line that I just drew? Why do you know that it is 1? Because it's a radius. Why are you saying that it is 1? As opposed to negative 1. Okay, so now draw this one. What is that guy's distance? 1. Why are you still saying it's 1? Because what are hypotenuses? Yay! Okay. Are we all good with that? Because it's a radius, it's 1. Cool? Okay, now, when I draw that radius, can I do any trig yet? Why? What? I need a triangle. Oh, Jenna! I need a triangle, don't I? Let's make this triangle. Whoop. Does everyone agree that I made a 90-degree triangle? Yes? Now, my 90-degree triangle, erase that. Now, how far did I go this way? No. 1 is the radius. How far did I go that way? Is it positive or negative? Negative. Do you know how far I went? So if you don't know how far I went, what do you have to use in math? A variable. What variable would I use there? Yx, Max. Why would I use x? Because I'm on the x-axis. So this is negative x, yes? Everybody cool? Okay. How far did I go this way? Y. Positive y. Correct? Everybody understand? Okay. So now I have... I erased my circle. Now I have an angle, yes? This blue line is just R, isn't it? Because it's the radius, yes? It's got no positive or negative. Everybody cool? Now, draw 3 more radii that are diagonal. And make your 90 degrees. Is everybody still cool? Yeah. So this was negative x. What's this? Negative y. What's this? Positive x. What's this? Positive y. What's this? Negative y. Everybody cool? And what are all of the blue lines? R. Correct? Now you guys are smart kids. I am going to take this triangle right here. R, Y, X. Tell me what sine is. Opposite over hypotenuse, yes? So what is it here? Y over R, correct? Everybody agree? Okay. What is cos? X over R. What is tan? Y over X. Agreed? Does everybody follow me? Yeah? Okay. So, what do you notice about all of those values? Values. Is y positive? Is r positive? So positive divided by a positive is what? Positive. Is x positive? Is r positive? So positive divided by a positive is positive. What about here? Positive. Everyone agree? So in this quadrant, everything's positive, correct? Look at what happens as we go around the circle. What happens here? This is quadrant 1. What happens in quadrant 2 while my computer restarts? You don't need me for this. This is quadrant 1. What happens in quadrant 2? You've got the same triangle, but what is y? What is y? Positive. And what is r? R is always positive. So in quadrant 2, what happens with sine? Sine stays positive. Cool? What happens with cos? Negative x over r. What happens with tan? Y over negative x. Everybody cool? Okay, so you tell me now what happens in quadrant 3. What sine? Negative y over r, because r is always positive. What's cos? Because r is always positive. What's tan? Negative y over negative x, which is positive. And what happens in quadrant 4? Sine is negative y over r. Cos is x over r. And tan is negative y over x. Does everybody see what has happened there? All right. So now that tells us go to the big coordinate plane there. And what does this tell us? In this quadrant, quadrant 1, what's positive? Everything. All are positive. Right? What in quadrant 2, what's positive? Sine is positive. What about quadrant 3? Tan is positive. And what about quadrant 4? Cos is positive. Now I know how much you guys love acronyms. C-A-S-T. Cast. Coses are positive in this quadrant. Only coses. Everything is positive in this quadrant. All. Sines, tans. Does everybody understand that? If you need to, you may want to draw what we just drew bigger over here. You should only need to draw one line to figure it out, yes? If I put a dot right there, that is a negative x, a positive y, and a positive r. Got it? I'm going to stop for a moment, let that soak in. Everybody cool? Everyone is cool? Now, what does this mean for you people? You guys should have some space, yeah? Okay. Somewhere in the bottom quadrants, so we're going to use quadrant 4, I'm going to give you a point. 6, -3. I lie. 13, 12, -5. Where would you put that dot on here? How would you get to 12, -5? Where would you go? I'd go right, 12, and then what? Down 5. Yes? Everyone agree? This is 12, -5, correct? What coordinate is that? Is it x or y? X. What coordinate is that? Y. Look at what we just wrote. X, Y, R. What did I just give you? X and Y. Can you find R? What is it? It's right here, correct? Nice drawing, idiot. How do you find R? Square root of what? 144 plus 25, square root of 169, which is 13. How long is R? 13. Does everyone agree with me? Now, without doing any math, knowing just the coordinates, do you now know the sine, cos, and tan of that angle? You do, don't you? Because sine equals O over H, but it also equals, what do we write at the top? Y over R. Cos equals A over H. From the beginning of grade 10, what does it equal now? X over R. And tan used to equal O over A, still does, but it also equals Y over X. And X, Y are just our coordinates. Right? And what is R? Square root of what? How did we find R here? Square root of x squared plus y squared. Now, if you know the x and y coordinates, do you automatically know sine, cos, and tan? Because of this. Everybody cool? We are stopping there because you need that to soak in. Tomorrow I will give you work on it. Okay? Everybody good? Okay. Now, one sec. On the board. What do you guys have tomorrow? SOHCAHTOA. Yeah? Okay. Now, that took a little longer than I was hoping. So, here's what we're going to do. I'm going to ask you guys for the last 8 minutes to you tell me the answers. Because if I hear the right answer, I'm going to remember it. Because I've done this sheet. Okay? So, what's the length of CD? 8.5 is correct. If you need to see why it's 8.5, ask me. How did you find CB? Cos theta equals x over 16. That would be fine. Right? Because CB, cos, there's my x. And what's your answer? Oh, that is the answer. Could you have done something else there? Could you have done something else there? Because you know CD is 8.5, couldn't you? Could you have used tan? Because you know this is 8.5 now. Could you have used opposite and adjacent? Yes. More than one way to do it. What is the height of AC? 8.5. Right? Because it has to be, because this has to be 45. They're the same sides. If you don't have what I have, ask. Otherwise, you're just marking. And straight line distance from A to D, 12-ish, right? Because it's the square root of 8.5 squared plus 8.5 squared. Yep. All right. Now it's easier because there's no real way around it. Now it's just answers. Straight line distance to the airport is 89.5. Okay? Everybody good? Angle along the ground east of north. It is east 65 north, I believe. Or north 25 east. Because of this. There's the airport. There's the plane. It's 3781. You needed this angle here. You found that to be 65. So you started, it's the other way around, sorry. It was east adjusting to 25 north, or north adjusting to 65 east. And the angle of elevation is 4 degrees. It's like 3.92 or something. 3.85, yeah, you round angles to the nearest angle. Everybody good? Everyone's good? Okay. Man looks at the cliff. Height of the tree, right there, is 52 tan 32. That's what you had to do to get that height. The total distance is 52 tan 32 plus 52 tan 67. I think it's 122. Yeah? Okay. Please notice this is the important stuff, yes? The two trees are apart, so it is 8, 50, and x, and 13, 50, and y, and then you got to subtract them. So it's 50 tan 13 minus 50 tan 8. And I don't remember the answer. But if you have that work, you've got it. Okay? This is what's important to me in a trig question. Fernie Island. Fernie Island, you go up here, it's 1750. Yes? I'll zoom in on that. $17.50, correct? Then I head over to sailboat leaves Roberts Point at 16 degrees. 16, hits Coal Island, goes over there. You find all of them. Using what? Sine, cos, or tan, whatever you want. There's no right way to do it, yes? Then you're going to get a hypotenuse, then you're going to get an opposite to 16, and you're going to add them all up. I can't remember what it is. But you know if you did the work right or not. It is going to be, the way I would do this, I would do, it is going to be opposite over adjacent. 1750 tan 16 plus 1750 divided by cos 16 plus 1750. You would add all that up. It's something like 4,000. Yep. Okay. And this one, this is the triangle. 800. Sailboat leaves at 307. So that's 53. Right? I lie. 307 leaves leaves Curtis, leaves Armstrong to Kingfisher. Oh yeah. So it goes there. 53. 800, and then you add all them up. What was that answer? I'll know it when I hear it. 930. What? 933. How can that be when this is 800?
I didn't get 933. I got.
So he sailed off here, right? He sailed off here. There's x. There's your hypotenuse. There's your opposite. Right? Right? That's the drawing, because he sailed over to Kingfisher, then over to Curtis, then straight home. So that had to be, you're going to have to use cos and tan is what I would use. And you would get the answer of, I think that it's about 1800. Needs to be about 8. That's the triangle you need. You need a 53 degree because 307 is 360 minus 307. You need 53. You need an 800, then you sort it out. Because directions don't matter, do they? Climbing the cliff. How tall is the cliff?
72.8.
72.8 is correct. The tower. It's this. $9.8 from the base. 9.8, 37. Oops, I did it wrong. That's one. 9.8 and 37. Then the other one goes all the way up to the top. It's 58 and 9.8. And then you do the math to find out how tall the tower is. So you find this height. You find this height. Then this height. Then you subtract for this height. And the longest suspension bridge is this. That's what a suspension bridge looks like.
Mine was right.
So 10.8 18.65. The towers are 135. So all you had to do was find x, y, twice. And it's something like 2,210. Everything on here is harder than your test tomorrow.
Quiz tomorrow.
Quiz
Is it
tomorrow.
on the stuff we learned today?
No, it's only on SOHCAHTOA.
Oh, that's it?
It's only on this review. Just triangles, just 90 degrees.
Okay.
Hi.
Okay.
Hi. So on check my mark, I have an NHI, and it's because I didn't write the review.
Yes.
Yeah, I got 15.
There they are.
Thank you.
Thank you.
Is the quiz tomorrow just like
Just
where's
triangles.
like what part of what we've done so far? Is it
This review.
just the
Just triangles.